Hi everybody and welcome. Today we're going to be talking about similar triangles and some of their properties. So your goal after watching this video will be able to apply the properties and identify when triangles are similar. So to take a look here, one thing that made me think of this was Lego houses. And if you've ever seen those Lego models, they're obviously much smaller, but they can proportionally kind of add up to the same thing. So this is something that somebody did independently and posted online. I thought it was pretty cool. It's proportional. It's basically the same shape, but obviously a much smaller size. One is real, you can live in it, and then the other one, maybe a very small rat could live in it because, again, it's a Lego house. It's not super big. So that's kind of the idea, is that you're modeling the same thing. One thing is just smaller, but they're both the same shape. And that's kind of the idea of similarity that we're hitting home today. So with that being said, let's first define similar triangles. And this is just when we have triangles with the same shape and proportional side lengths. So the idea behind this, again, is that, it is the same thing, the same basic idea here. It's just one is really big and one is really small. Sometimes they're closer in size, but again, kind of that same idea that, they have all the angles that are the same. It's just the sides are a little bit different. So if we're looking at like triangle 1 and triangle 2, triangle 1 is similar to triangle 2. And that is how we say similar. So similar is not like, oh, it's the same shape, kind of. It's like, no, it is literally exactly the same shape, just one is a different size. All right, so there are 3 different ways that we can identify these. These are things that we're going to use in proofs. So take some careful notes here. Make sure you save these because, again, they are going to be important for proofs. We are going to need them, and it's going to come up pretty frequently, so a good thing to remember. So the first one is AA, angle similarity. So if you have 2 angles that are the same, basically it says that they're similar. So if the 2 angles of one triangle are congruent, we'll use our congruent sign here, to 2 angles of another triangle, then we can say that these triangles are similar. So all we need is 2 angles, and with 2 angles we can say for sure that these things are similar. So here, PQR, similar to TSU. All right, keep it going. SSS. So remember before SSS, all the sides, that did not help us in terms of, so I'll retrace there. So side, again, we might see some of these things that came out in the past for congruent triangles, but they're going to be a little bit different for similar triangles because we're not saying that they're exactly the same, we're saying that they're proportional. So let's go through this one first here. If the measures of corresponding sides of 2 triangles are proportional, then the triangles are similar. Previously, with the side, we said if they were congruent, then they were the same. But we're not trying to prove congruency here, we're just trying to prove that they're similar. So in this case, we see that if we have a ratio of like, A over B for this triangle on the side, then maybe we could put AX over BX. What we're gonna see is that we're multiplying A and B by the same thing, and that means that they're in a proportional relationship. So that means that it's a constant ratio. So if you divide A by B, it's the same thing as if you divide AX by BX. So again, back to those ratios we were talking about before. If we're in that constant proportion, we're in good shape and we'll have some similar triangles again. So PQR is similar to TSU. All right, our last one here, side angle side. Again, we used to use these to prove that they were congruent. That's not the case here. We're trying to prove that they are proportional, so it might look a little bit different. So again, just be careful when you're applying these here. So this says that if the measures of 2 sides of a triangle are proportional, so again, not congruent, but proportional to the measures of 2 corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So again, proportional relationship here, and we know that our angles are the same, so we can again say that PQR is similar to TSU one more time. All right, so some practice there, some theorems that we're going to be able to apply. We'll do one example together, then you'll have 2 opportunities to practice. So in this figure, they're telling us that FG and EG are equal. So if we remember that, that's an isosceles triangle. We have two equal sides, so we know for sure that the angles that are across from these are also equal. So we can just draw that in. I'll do it in a different color here. We know that this angle is equal to this angle. So if we're looking at this here, the next thing that we'd probably want to do is see if we can prove one of these theorems. So we know for sure that we have angles that work for our, and I'll highlight these. Here's one triangle, and here's the second triangle here. So we want to see if we can, in some order here, maybe prove that we have like a side, an angle, and a side. And then we can do the same thing for the other one. Again, I'll show this in a different color. We would have this side here, and this angle. So that would be side, angle, side similarity, the last one they talked about. So we already proved the angle. Now we just need to prove that our sides are proportional. So how do we do that? Well, let's take a look at our bottoms. AE is our bottom for our left triangle. And for our right triangle, setting up this proportion, I believe FD or DF is our bottom. And then now let's go for that side length that goes up from the ground here. So CF for the one on the right is 20, and BE for the one on the left is 15. So again, important that we match our bottom to our bottom and our side to our side here. And then now we can do what we were doing in our previous lessons, some cross multiplication. So when we go through and we do this, we're going to find that 20 times 9 is 180. 15 times 12 is also actually 180. So because both of these equal, we can say that yes, these triangles are proportional, which allows us to say that because we have proportional sides and equal angles, we have proven our side angle side similarity. So we can say that ABE is similar to DCF. And again, a lot of different combinations here that you can say, you know, ABE, you could say EBA. As long as the one on the left matches the one on the right and is in the correct order, then you're in good shape. And that's what we were looking for here, is that proving statement, seeing that we did SAS, seeing that we have proportional sides, seeing that we have those equal angles in here, and we are in good shape. All right, for our remaining two examples that you don't have to complete and submit, a couple things for us here that might help you out. They're telling us that RS and TU are parallel. So what that means is we have, if we were to like trace this line out, we know that this angle and this angle are congruent. We would also know that this angle and this angle are congruent. So there is your angle-angle similarity. So now you have to prove that these side lengths are proportional to these side lengths. So set that up and finish up there. And then finally, for our third example, we're measuring the Sears Tower. So proportionally, we have a 12-foot light pole to 2-foot shadow. We want to see what is the height of the Sears Tower if it has a 242-foot shadow. Because it's measured at the same time, we know that the angle from the sun for both of these is the same. So this angle is the same for both. We also know that these are both right angles. So again, there is your angle-angle similarity, which allows you to set up your proportion. So again, put your sides over your sides, and you'll be able to solve for x equals. And the same thing up here, solve for x equals. All right, so a little bit of vocab today. Again, make sure that those notes stay detailed and organized, and you'll be in good shape for these questions. As always, feel free to reach out with any questions, email, Teams chat, any of those things. We are here to help. I appreciate everybody tuning in, and I will see you all